Hi friends, we are going to discuss now meter bridge, that is 3.15 meter bridge. What is meter bridge? Let's see first. The figure of meter bridge is as shown here. This is L-shaped copper strip, right angle corner, one strip. There is a gap, another strip straight, then third strip, it is L-shaped. So meter bridge, it consists three copper strips, one straight and two L-shaped right angle corner. These three copper strips are fixed on one wooden plank or wooden platform. These are fixed in such a way that there are two gaps between these three. This is one gap, it is another gap. There are two gaps between these two. Then next one, these are copper strips. It consists, first one, copper flat strips, meters. Then it consists 100 meter long wire, 1 meter, not 100 meter, 1 meter long wire. It is not 100 meter, 100 centimeter long wire. Second one, 1 meter wire. It is stretched on the wooden board and fixed. One end of the wire is fixed to this copper strip, other end of the wire is fixed to this copper strip, and wire is always stretched tight. It's not a wrinkled one, it's a stretched one. Third important thing is that the area of cross section of the wire is uniform. Uniform area. Its area is of same radius. It's a uniform area. Then next one. This is point A. This is point B. This is point B. This is point C. Then here battery is connected. It's a plug key. Key is there, battery is there, plus minus. So EMF source, battery is connected between AC, and whenever we want to make a circuit, we can close key. When we want to make it open, we can remove key. So key is for make and break of the circuit. Next one, there is one galvanometer. One terminal of galvanometer is connected to B. So next one, it's a battery. It is AC, key, K. Galvanometer, one terminal is connected to B. Other terminal of the galvanometer is given to jockey. What is jockey? Jockey is metal rod, like a knife edge. One end is like a knife edge. So if you see this one, this is the jockey. Here it's a knife edge is there. So it's a metal rod with knife edge end. One end is like a knife edge. So it's given to this jockey. For what purpose jockey is used? We can touch jockey at different points along the length of this wire. Thereby circuit can be completed. So whenever we want to make circuit, we touch jockey at different points of this stretched wire. Wheatstone's meter bridge is based on Wheatstone's bridge. We all know. Suppose that now this is used to find out unknown resistance. It is based on Wheatstone's bridge and it is used to find out unknown resistance. It's a R, is unknown resistance we want to find out. This unknown resistance is connected in one gap. It is connected here. It is R. Then in other gap, known resistance, which is known as S. Mostly, the variable resistance box is connected here, thereby we can change it suitably. But this one is always known, S. Now unknown is connected here, known is connected here. Plug key is fixed. Current will pass through the circuit. As soon as current passes through the circuit, galvanometer must show deflection. But it does not, because the jockey is not touched anywhere along the length AC. Then first touch jockey at A. Galvanometer will show deflection. Suppose that it is showing deflection towards left. Then touch jockey at C. Again galvanometer will show deflection. But in this case, galvanometer must show deflection in opposite direction. Previously it was left, then it is to right. Slide jockey along the length AC. We slide the jockey along the length AC and somewhere, this is point D. Even though the jockey is touching to the wire, galvanometer shows no deflection. When we touch this jockey along the length of wire, even though the jockey is touching to the wire, galvanometer shows zero deflection, no deflection. What does it mean? It means that the balancing condition is obtained. Let this side be length L1. Total length is 100, so automatically it becomes 100 minus L1. From this one, let us take RCM is resistance of wire per centimeter. RCM is what? Resistance per centimeter, and it is for wire. So R centimeter is a resistance per centimeter, and that is of wire. So obviously there are 4 branches. We know this one. R by S is equal to resistance of AD, RED, resistance of AD, divided by resistance of DC. Resistance of AD is equal to R by S is equal to R centimeter into L1. Resistance of DC is equal to again R centimeter 100 minus L1. It's getting cancelled. So R by S is equal to L1 100 minus L1, or R is equal to S L1 divided by 100 minus L1. We know S, it's a known resistance. We find out L. If we get L, then automatically unknown resistance is found. In this one, the reading should be at the middle part of the wire. Always reading should be between 40 to 60. Then there is a less error in such case. What are the possible errors? See that at the point, contact point, area of this tree and area of wire are different, and therefore here the resistance of wire does not remain uniform. Similarly, at this contact point also the resistance does not remain uniform, and because of this one the error creeps in the reading. But to avoid or to minimize this error, if we take reading in the middle portion of the wire, then the error is compensated at large extent. And because of this one, the reading is always taken between 40 to 60. To get minimum error, reading is taken between 40 to 60. That's all for this. Thank you.